Right, welcome back everyone. So I hope you can see the screen clearly and also you can hear my voice. So if everything is okay, so I need to do some logistic. So first is can you please put down your particular um, uh, for the record of the attendance. And also if you feel that the screen or my voice or the smoothness of the streaming is not really okay on your side. I'm not sure whether is it because of my internet connectivity or from your side. So just make sure that everything is okay and please put down your name, right? Thank you. So that's the first thing. So without further ado, let me start for the second class. So today we'll talk about service robot system. So I will give introduction. Okay, first, the arrangement of today classroom also divided into two parts. The first is I will give an overview, okay, and particularly I'll focus on the service robot system that we use in our community. So which means the robots system that we develop in our competition, in our workshops. So we'll focus on that and give everyone an overview of how it is look like, what is the building block inside, and then what are all the research and development component. Then I will explain also in detail what are all the building blocks inside this basic robot platform that you can actually build following our workshops, hands-on workshop program. And also, I will try to trim down the requirement to come up with the version that match with the online classes that we are going to do it after this. So which means I will trim down everything to show you that you can actually build something with whatever materials that you can find in your home and follow our class so that you can have some fundamental idea and also the development skill how to build a robots, particularly service robot. Okay, so that is the first overview. And also for user who are actually doing R&D research and also who are doing teaching in related subject. Today also I will show you some research and development that I have been doing with this platform, right? So that will cover the content for the overview. Then after that, I have the second part, which is which is the development setup, right? So for development setup, so today I will go into the detail that how you can actually start to prepare the development environment that we need, the system that we need. Okay, so in practical is the laptops that I mentioned last week, the laptop for development. So I will tell you what operating system, what software, and how to configure with the hardware that you have, the speaker, the mic, the webcam, and so on. I will tell you how is the arrangement of the required system. So in order for you to prepare for the development that I will start to introduce to you. Next week, I will start with Ross. So I will start with some basic information about how the development can be done. For example, next week, I will show you how to do some simple coding. Yeah, next week, start from next week onward, we'll do some simple coding. So today still is quite a lecture type of presentation. So next week onwards, I hope everyone can prepare your own development system, and together we will start to do the, we will start to do the programmings so that you can create some application at home, right? Okay, so that is for the scheduling for today. And also, I would like to stress here, so today I only created one Zoom session, which is with this ID 285278205. So if until 40 minutes later and it cut off, so we will just reconnect with the same. So what I will do is I will close this session and I will start again using the same ID. Okay, I hope it works in this way. So I will start with the sync. So you just need to reconnect to the same session. All right. So hopefully this is working. But if anything is not working or this is not working well, I will quickly create a new ID and I'll post it on our website. Okay, I'll post it on our website. So which is on the okay, let me show you. So this is, oh sorry, I need to put this thing down. So I will put it here. Right, so I'll put it here. If anything happens and this ID cannot be used after this, so I will update this link and we will continue from there, right? So I will reserve 2 hours mainly for this session, and hopefully like we can continue with the same ID for the next session as well, right? So I'll continue over here, and then you can start opening up the slides materials over here. So I already put up the materials over here that you can refer to. So which is, I'm also using the same thing. So over here and here, this is the first part and this is the second part. Okay, so you can refer the materials here. And for the video, like last week, the video I'll put here, and the finalized PDF I will also like put up after the session. Okay, so that is the order arrangement. Okay, right. So let's go back to the attendance. So I hope you can actually put down your name. I'm not sure, like I have 29 participants, but yeah, not many people actually written. So can you like put down your name, please, so that I know who attended at least. And also, yeah, I'm not sure, like you can like our Facebook page and join the group, right? So we have created the group and we have a lot of members gather last week. So the group that is, okay, I also want to show you the group, which is you can go to our group. Okay, so sorry. So it's on the last slide. Okay, let me go to the last one. Okay, this logistic thing first, maybe I just explain. Yeah, so just go to our group and join the group so that we can actually have more updates over there. So I post most of the updates starting from last week. So I'll post in a group and hopefully you can see our updates. And also if you want to ask anything or you have any comment or feedback, you can contact us easily from this. Yeah, no problem that you didn't join the last class, okay? So just you can come anytime. And of course, we have some relationship between all the classes, but you can join anytime. And if you miss any class, you can always go back to this page and you can see the review. Sorry, the replay, right? So you can run the video, which is the record. So I'm recording for today as well. So this will be up after the session over here, so you can see back what is happened during the class that you missed. Okay, right. So let's go back to today's. Go back to the first one. So I have quite some materials to cover today. So maybe I'll go a little bit more faster this time. Okay. So first, let me have an overview about what is the research and development in service robotics, particularly on our using our platform. Okay, first I try to put everything into something that is very easy for you to link with. Okay, instead of telling you a lot of technical terms, so I put it in a very simple form with the metaphor of like human sensors and human anatomy, so that you know what the relationship and how it actually work together. So similar like how we did. Right, so okay, so someone actually asked me about this. So this is the link, so please put down your name, okay, at least, and also your email so that we can keep in touch. I know like some of you may be new, but regardless you have attended last week or not, please join and put down your information so that I can keep track on you and also update with you if we have any further information. Okay, so it's for the community communication. Right, so I divided service robot into this 5 parts. So this is a basic service robot component. So if you want to build a service robot, I think these are the 5 components that you need to actually put into this system so that it can have a complete system that can work for the services that you want to develop, right? Or for whatever application. But of course, this is just a very basic and general configuration. You can have very specific requirement based on your application, but just for the sake of this online courses that I'm going to introduce you some example, so I will use this as the basic components. So we start with the first part, which is the robot mouth and ears. So this one is actually for the human-robot interaction. So as I mentioned last week, it is very important for service robot to interact with human, all right? People around, the user. So not just the master or whoever that own the robot. The robots might need to interact with other people. For example, the guests, people that you don't know, especially if you put in retail, you put in hospital, you put in some public places. So you cannot, how to say, have a finite groups of people that you design to interact with. So your robot supposed to be able to adapt itself so that it can interact with many people, okay? And the second thing is it need to have the robot eyes. So it's the eye that it is the visual perception of the robot in order for the robot to understand the surrounding at itself. Okay, so it need to know like how it is located in the environment, how what is the distance between himself with the object. For example, like is someone standing in front, so we can detect someone in front. We can detect some object in front so that he can do something, right? And he know like the relationship in 3D space, like how far this object is, and what is this object, who are these people, or how many people, right? So this is for the visual perception. Then the third one is the leg. So this one is very straightforward. I think everyone can understand. Is for the navigation. Navigation means the robot able to move around like normal human being. You're able to move around in your environment in order to do a lot of work, application, and so on. So you need to, the robot cannot be stationary at a point, but it needs to be able to move autonomously. So this is very important. Move autonomously, which means you cannot write down the path initially. It needs to be able to find its own way during that situation, because like things change. For example, like the obstacle moving, like people moving around, you got other obstacles that will happen throughout the whole time. So the robot need to be able to plan a path from point A to point B at any moment. So this cannot be pre-planned. It needs to be able to look at the current situation and plan a path from point A to point B. Okay, right. And also the ability to use map, for example, and also to explore some place that you know. So we have the online mapping and also the offline mapping as well. Right. Then the next component is the arm. So this arm, the basic functionality of this arm is to manipulate the object. So for example, you need to get something, you need to grab some bottle, some object, anything for certain application. So the robot arms have to be able to do that. But maybe this arm is not as strong, and maybe it is just one arm. So it is not as flexible as human being arms, but at least it can do some physical tasks. Yeah, because without an arm, it is very hard for the robot to do anything physical. Like you need to like press a button, for example. You want to take the lift, you need to press the button, you need to do some stuff. But this one is a very simple configuration that it has very limited working space. So which means it not really as flexible as what human being can do. But over here, we would like to show you some fundamental knowledge about how to control an arm and do some simple application. And of course, anything that I mentioned before, all the component you can actually extend in your own design and so on once you have understand the fundamental. And lastly, of course, this is very important, is the brain. So it's the computing unit to make decision. Okay, it's not just actually not just making decision. It need to first process all the information that's coming in. So we have a lot of information from the visual, from the audio, from moving around, the sensors for the robots to navigate and so on. So it need to process a lot of data. And then from this data, the robot need to understand, okay? Need to understand. But this understand is very different from human understanding. It's different. It's how the robot perceives the environment, and then the robot need to do some decision making. Okay, for example, it need to continue moving forward. It need to say something. It need to find something, track something. It need to go somewhere, and so on. Right. And over here, not only the local computing devices that we focus on, we also focus on connect to the cloud. We use cloud resources, and also we use a lot of big data outside there for the decision making as well. So over here, these are all the overview of service robot system that we are going to discuss for this session. And I will share with you one by one how I actually develop all these things, and also how to put them together to create a complex application. Okay, right. So let's start with the first one. So first is mouth and ear. So this one is for the human-robot interaction. So it's very, I think it's very easy to understand that you need to be able to do the speech interaction. Okay, so that is a very fundamental layer for the robot in order to understand and also interact with people outside. Okay, so let me show you the scenario or the actual things that happen. And maybe this is quite loud, so let me see it. Yeah, I need to show you the voice. So this is the actual situation happening. Yeah, I hope you can hear. So for the speech interaction, so these are the few components that we develop. So we have the speech synthesis, which is very similar, like how to say, robot voice that you type. You know, like we might maybe come across of this before, like you turn on the speech features of your Windows system, and then you put some text onto the command prompt, and then it will actually read out. Okay? And then you can switch the voice from male, female, children, and so on. Then you can hear something. So that is the first development in speech synthesis. So the machine able to say something. Then after that, we have speech recognition, whether it's offline or online. Nowadays, we have a lot of online Google Web API and so on. So very similar like your phone series, Google Voice, and so on. So you can say something and the robot able to hear you and translate that into text, and then it start to analyze what are the words or sentences that you just speak to the machine, and from there it gives some feedback. So that is the speech recognition. And also, although I written here mouth and ears, but it actually more than that. Okay, so it's not just it's multimodal. So we have a screen on your laptops and so on. You can have some icon, emoticon, or whatever way that we develop in order to give some expression. Right. Okay, so let me show you what happened during our development. So this is this video taken in one of the competition to show you the actual scenario, the speech part works in our robots. Okay. So maybe you can. Which operating system are you using? Very noisy. I have the text out there to show you what is actually the robot say and so on. Okay. Right. So what I want to show you here is like in the actual condition, the challenges is to make this system practical. Although speech recognition, speech synthesis has a lot of very how to say, matured technology, and especially like when you deal with how to say, smart speakers. We have the Google Home, we have the Amazon Echo, and so on. So the human voice interaction with machine or whatever smart speakers and so on. And this technology is already like very popular. Okay, but what we focus more on in this development, in service robot development, is not only contactless, contextless. Okay, so which is what we want to say over here is like our speech or human robot interaction is more than just exchange of words. Okay, but more on exchange of information based on the current situation. So just now, when you look at this video, so one thing you can observe is the noise. So we need to deal with a lot of noise in the environment because we are going to use robot in real environment, which is like we may have a lot of other user, we may have a lot of other operation happening in surrounding. So it's in a 3D space, it's in a real environment. So we have a lot of noise. So that is the first challenge. The second challenge is we have people speak to you in certain direction. So which means we have the embodiment. So you are speaking to the first person. You might have a lot of people, like over here, you can see the user are standing around the robot and speak to the robots one by one. So the robot need to able to know also where the sounds come from. So we have also the challenges of identify this sound come from this person. So we try to link this sound to this person and so on. So, and also the context of the current situation. For example, in Google Home and so on, it may don't have the information about, if you ask the robot, so what is, who is the person standing behind me or in front of me? And it cannot answer you this kind of question because it don't understand your local scenario. It don't understand your current context, right? The context is very important. So context, based on the context, the current context, the interaction is what we need in service robot. Okay, so over here, and not just the speech, we also try to come up with something like face recognition, face expression, and so on, and also even body gesture. So these are the things that not appear in Google Home or Amazon Echo and so on. So a big difference if we want to develop this speech or human robot interaction in service robot, we need to deal with physical space. We need to deal with physical human, embodied human, that we have the space and time information. So the robot need to know like, okay, yesterday about this, today about this, tomorrow about this. And this person says something, you need to understand, okay, this word is from this person. And then tomorrow, the other person says something, then you need to understand that they are the different contexts. So different people talk to you will be different, right? So you need to respond according to this kind of record, which is, this is totally out of the scope of the smart speaker or whatever intelligent speaker or series or any this kind of speech only application, right? So that is the first part of the speech. We have a lot more. In fact, next week we will start. So next week I will start to show you how you can use your laptop. Okay, next week. Okay, but of course next week we will start with ROS fundamental. The following week, yes. The first module that I'm going to show you is I will show you how to build a smart speaker. Yeah, a smart speaker. I will show you how to build a smart speaker, but more than that. All right, I'll show you with just your laptop. Right. Then later on, you add on the visual. That will show you how you can do something more than your smart speaker. For example, you can talk to your robots, which is your laptop, and who is this person? And suddenly the robot able to recognize not just you, but maybe your family member as well. And then you can talk to a different thing. But of course, I will show you what system you need. Like Windows, if you have a Windows base, don't worry, okay? The second part of this session, I will explain to you how to prepare the system that you require, right? Okay, so let me go through all this material first. Then we have the eye, which is the visual perception. So over here, I show you an example of this. This is a follower. So the robot will follow. So we use visual perception, okay, to track, to see what's happening in front, what's happening in the surrounding, right? Visual. And for this visual, we are using this RGBD sensor, which is not only the camera system or not only the color information. So we are not using just the color sensor, but we're also using this infrared, which is over here. It uses infrared because this is the Kinect sensor. We use optical-based range finder in order to detect the range. And this range, if we go for 3D, so we actually obtain some information like this. So this is what we call point cloud. So if you plot the point cloud into according to distance, so we will get something. So the information is we will get the 3D depth data, right? So these are the data and also the color information, which is the color information like the image, like what is the person look like in front and so on. So you have the RGB, which is the color, and D is the depth. So we have these two information together, and that actually gives us a lot of information to perceive what is the surrounding, including people and environment and object. Okay. So with this visual perception, we can do a lot of processing for recognition. For example, like over here, we use a lot of deep learning based image processing. For example, like on the left, I show you an example like this is real-time object detection using YOLO. YOLO is object detection framework using deep learning with like you can train yourself with a lot of data. So in real time, you can recognize object, right? And also this the accuracy and also the robustness of this system is pretty high as compared to the convention pattern matching, is because like you have more data and the robot able to learn to adapt to some changes. And the video on the right hand side actually show you face recognition and also gesture. So because like in this environment we actually have a lot of faces, right? Then the robot's supposed to not just detect only the face but the gesture, right? So the gesture is something, the action, not just a static information, but it's a moving information. It's an action that you need to recognize. So we can see like, yeah, this one. So you can see like we recognize the face and we recognize the hand, the gesture, and that actually that is the part of one of the example development in our robot building experience. So these are all the tools that I'm going to introduce to you along the way, and this one will cover in the image, in the visual perception session. Right. So just to show you why the deep learning or whatever the new way of visual system or vision technology and so on, computer vision, yes, the new generation of computer vision technology is very important, and also it's very useful nowadays. Because for example, like this was one of the results that we obtained in 2016 from my team. So over here, we need to recognize not just the faces, but also we need to recognize, for example, female, male, the gender. And then over here, you need to understand the difference between recognition and detection. So for detection is you, in one picture, how many faces are there, right? So this is detection. Recognition is among all these faces, the first one on the left and so on belongs to who and who, the name, right? Because and the second one belongs to who, which means you can associate this face to this person, right? You know the name. So that is the recognition. Or you can associate like this person come to me yesterday. So you recognize, you remember, the robot able to remember some faces that it recognized before, and it store as a data, and it put some annotation or label as, okay, this person appear like yesterday, come to the shops and buy something, so and she or he come again today. So that is recognition, right? So over here we do a lot of we have an example in our visual perception class later on. So I will show you both the idea how to do detection and also how to do recognition. For detection, it's actually not very easy if you just do pattern matching, because like nowadays, we need to detect faces that we never see before. Yeah, it's because like, for example, you have a surveillance system or robots that station in front of a bank, for example, or school or whatever. that you need to greet the guests. So you never know who will approach the robot. So how to actually recognize faces without the face that you know before is something that we use, like the big data and also the deep learning method, to actually recognize or train the system with a lot of information about the faces, how a face look like, without need to have any similar cases before, right? Okay, so in visual perception class, we will talk a lot about this. And a very interesting part is like, apparently some very similar to face features. So you can see like it is actually recognized using features like how the eyes and the mouth and also the shape of the face makes the robot detected this logo as a face. Okay, but it is not wrong actually. It is a robot face, right? And also this one looked like a male. Okay, right. But anyway, this is the actual results that we obtained with our vision system in 2016. Right, and deep down for research point of view, in service robot, we actually talk a lot more than conventional vision system research. For example, like in our actual scenario, for example, service robot application, we deal a lot with this illumination condition. So for example, our service robot is, our robot actually operates in a home environment. So for example, your house. So you can observe easily that the lighting condition in one room is very different. For example, over here you can see like this picture, like in this corner, for example, like this object, if you want to see now in the morning, so we have the morning sun and it is very bright, so the image is overexposed, for example. Then suddenly it rains and then it becomes dark, and yeah, the whole thing looks very different. And also, we might need to manipulate. For example, you need to move this bottle into this shelf, which is very dark, a lot of shadows and so on. So everything changed. So over here, again, we use some cycle gun, which is a very popular gun system, deep learning method, to learn. So that the learning part is very important for the robot able to adapt the changes, how the thing looks like when your illumination condition change. Okay, so this is one of the research that we do, and this kind of topic only appear in our application because, for example, in the vision system or in the computer science group, they seldom talk about how you want to use this thing when your camera is moving, right? Or when you are operating in a condition that the illumination condition changes over time, from the morning until afternoon until at night and so on. But we face this kind of problem because we build actual robots that work on this kind of application. So these are one of the new domain that service robot research heading to. Okay. Right. So the next part, we talk about autonomous navigation. So the leg part. So over here, I show you what exactly happened. We have this SLAM and AMCL system. So SLAM is stand for simultaneously localization and mapping. So it's the technique in mobile robots. So this one exists very long. So it's a very matured and also very well structured function in mobile robots. So it can actually use a lot of laser rangefinder, laser scan to build a map, a 2D map. So this is a map looking from the top. So we can build a map. We have all the marking of all the wall and also some permanent obstacle, for example, furniture and so on. And also we have non-permanent obstacle, for example, like or dynamics obstacle, which is like, for example, human pass by and so on, which is not appear on the map, but the robot able to like respond so that it don't actually crash into someone or something in real time. So the autonomous navigation and also obstacle avoidance in real time for statics and dynamics obstacle. So these are all the techniques that's very important in order for the robots to move around safely in your environment. And these features is very important for service robot in order for the robot to operate in any environment, actually, in for example, house, in hospital, in station, in retail, in supermarket, and so on. So these are all the scenarios that's going to happen. So how the robot able to respond to all these kind of changes or dynamic behavior in the environment in order to safely navigate from point A to point B. So over here, point A and point B, you only tell the robot where to go, right? But the robot you can see this red color line over here. So this is the path planning, right? The path planned by the planner inside the system. So in the navigation class, so I will show you how this system can be done, even without understanding the underlayer of how SLAM is work, how to use SLAM to build the map and so on, without knowing all the calculation, without knowing, for example, this AMCL, without knowing what is AMCL, right? Without knowing how the robot actually localize and so on. But I will show you a way how you can use the existing open source tool, which is the package, in order for the robot to able to do this thing. And also because this is an online class, so I will replace the actual robot with simulation model. So you can do this whole thing exactly the same, even your coding is the same, just you switch between to the real robot or to the virtual robots, okay? Everything will be the same, and you able to learn how to do the mapping and how to do the navigation. Yes, right? So don't worry, with whatever that you have, just a normal laptop at home, we can still, I can still show you how to do this, and you can learn how exactly SLAM and AMCL and all this obstacle avoidance works. And you can actually integrate this part with other parts as well, right? Okay, so this is for navigation, and also we have the object manipulation for using ARM, right? So over here, okay, so this is the video. Okay, so we have a 5 degrees of freedoms, a very simple arm with 5 servo motor. So for those participants that play some RC car or some simple robotics before, you know what is a servo motor. So this is a servo motor. Okay, so which is to control the angle for the turning, the turning angle, then it will rotate the joint, right? So with the joint and link, we build up something like this, which is what we call the turtlebot arm, and then we mount this arm on the robots, and it works together with the base. So this system, it actually extended from the conventional industrial arm application into something what we call mobile manipulation. Mobile manipulation means the arm is able to move around. So it actually extends the working envelope of the arm, and it's able to grab something out of the boundary initially by moving forwards or moving close to the robot or moving over the working envelope of the arm, right? So over here you can see like this is how this robot able to grab this from far location. So it come from another point, come to this point in front, then it start to detect, it start to align itself. So we can see like there's actually a sensor down here used to detect this object. So it detect, it align itself, then it start to grab. So the whole grab strategy, not just based on the initial condition that whether the arm or the object is within the arm working envelope, but we can actually ask the robot to go to certain places to find something and to grab the thing and come to you. And this is very important application in service robot. For example, like you want to build a robot to help, for example, the elderly to get something in the house. So the elderly, your grandparents or your parents, you just need to tell the robot like, okay, go to the kitchen and get me a can of Coke. Okay, so the robot able to like move from the living room to the kitchen and then try to from the kitchen find the Coke of can and try to grab it and for you. So this kind of application is very specific to service robot that we are dealing with, and we use all this technology from navigation to speech to arm, put them together in order to realize this kind of application. Okay, but of course, this time because you don't have a physical arm, so we will try to replace with simulated in a simulation. Right? Hopefully this is okay. I'm still working on this part, but hopefully you can experience how you can control an arm very similar, although it is in a simulated environment, but it's very similar to how it operates in the real world. Okay, so just to show you some research work that we have done in my lab, my students. So what we do is like we extend this manipulation development, and we combine the arm, the manipulation research with the navigation. So over here, we want to do a robot that able to, all right, so you might ask me like the arm for cooking. Cooking maybe is too complex. Okay, so I'm talking a very simple movement. For example, grab something. Okay, grab something. But for cooking, you need very precise control of the arm. For example, like you need to use tools. For example, you use a spoon, you use chopstick to do something, or you use your ladle to fry and so on. So it is actually very complicated thing. So over here, I will show you something very simple, like move the arm to do, but the fundamentals are the same. All right. So if once you learn how the arms move to a particular target, and then to do some operation, you can easily go deep into it. For example, you change a more precise arm, change a better motors, or you change the gripper design so that it can grab some tools and so on. Then after that, you improve your accuracy in terms of the control and so on. But of course, the underlayer concept are still the same, right? So if you are interested on this kind of development, eventually you can start from this class, you learn the fundamental thing, then you can upgrade your arm, you can upgrade whatever software to make it more accurate, your algorithm to make it more accurate to the requirement of your operation, for example, cooking and so on. So, but of course, in between, you need to add a lot more. For example, you need to add pressure sensor, you need to add a lot of sensors in order to get higher accuracy for the movement of the arms in order to carry out your operation, right? But over here, what I want to achieve is I want to show you something that you can do now at home, right? So without have the arm or the complicated hardware, I want to show you the fundamental concept, and you can actually realize it. I mean, like materialize it. You can see how it happened. You understand the basic concept. Then from there, you can extend from there, right? So that is the purpose. So over here, the research that we do, that every time when I talk about all this development, it's not that I'm doing something that people haven't done before, but I'm just want to show you that this is something very different from the conventional thing. The conventional manipulation research and also the conventional navigation is very different from what I'm doing here. So what we're doing here is like we combine these two, we come up with a new direction in the community, research community, we call this the mobile manipulation domain. I mean, like mobile manipulation example of research work. Okay, so over here, what we try to do is like we want to create robots to tidy up the room. So you can see like this, for example, this is a living room, and after your kids play all the, all the toys and it's scattered around on the floor, you have like the Lego piece, for example, you have the soft toy, you have a lot of things. Then the robot, we want to design a robot that's able to actually grab all these pieces and then put them back. First is like using vision, you try to recognize and classify them into like different things, soft toy, rubbish, or Lego pieces or whatever. Then it's able to sort this thing out and put it back to, for example, like you have a box for the Lego thing, you have a box for the toys and so on, and also maybe you have one rubbish bin, which is all the rubbish supposed to be into the rubbish bin. So in this project, we try to use all these service robot component to create robots that sort out all the component or whatever objects that on the floor to the respective storage. Right, so the last part of the service robot that we developed, okay, is about the brain, right? So it's the AI, the intelligence. So we use a lot of machine learning, cloud computing techniques for this kind of development. So over here, one of the things that is very important for us is the ability to shift the computing requirement to the cloud, right? Yeah, because we are building a very simple robot, so we don't actually have a very sophisticated or very high-end specification for our robots. So we just use a normal laptop on the robot. So we try to focus all these resources on the local operation. For example, the navigation, to get the data from the sensors, to process the data, and so on. But we want to push all the computing power that not require on board to the cloud, right? So we know that now we have very good connectivity, like Wi-Fi connectivity, very strong signal, especially when your robot is working indoors. So the connectivity is not really a big problem, but maybe of the latency and so on. Yeah, still, but we hope for like 4G, 5G is coming, and this will eventually solve all the latency problem, right? So we put that as an assumption, and we design a robot so that we try to shift the load for a lot of non-local processing thing onto the cloud, so that we can have a big server behind there to help to process all the complicated stuff. For example, your speech recognition, your object recognition, and all those things actually can be loaded on the cloud for processing, right? And a very simple application or a very simple example that I can give is, now we have a lot of speech and visual all these services that are available online. For example, your Google API, for example, your Amazon speech API, and so on. So you have a lot of all these API available on the cloud that we can utilize. We can leverage this kind of very strong thing to use it on. So for example, you don't need to process your WAV and then to understand, like, you have a big database to do the pattern matching for the words in order for you to do the speech recognition. So we try to shift everything, and we try to have our all these processes able to be done on the cloud. So we just use all this thing to enhance. And also another benefit of this is, like, we actually not able to create such system on board. For example, like the Google have a very big database behind to support the speech system, which is not really not possible that you can have this kind of very powerful system on board, right? So this is a very good combination or configuration, I would say, to try to focus the resources, the computing resources on board for the local processing, and put the, how to say, very complicated or very, how to say, not really related to the local processing. For example, when you do the mapping, you need to do the movement of the robots compared to the maps and so on to control the motor. So all these things we can done local, and then we can shift the brain. Okay, so the brain, because this one we talk about the decision making, so we can shift a lot of that not require the local resources, we can actually put on the brain. So we shift the brain to the computer on the cloud, and then we can have a very good combination of these two to make our robot very powerful. Right. So over here, I show you, like previously, we have one example that we can do some learning from one robot, and then we can share on the cloud on the database. So this shared database can actually make another unit of robot able to understand things without even learn. We can share the knowledge and so on. So this is a very good point of robots, that we can have a shared memory, not to say share memory, share experience. So it's very different from human, because like, but actually very similar like how human do. For example, like you learn how to cook some dishes, then we put this knowledge on YouTube. Then another person look at YouTube and understand, and then it got the idea or the knowledge how to make the same dish out. So we actually put our knowledge or experience on the cloud, and then the other person able to get it. So very similar, like the robot can use a very similar thing, but maybe this whole process is not very same format. So it is not shared like YouTube video and so on, but it's in a digital form. But the concept is very similar, right? So we can have this kind of configuration for our service robot application. And then the robot will be able to do a lot of things. Even you don't need to like use a long period of time to obtain all this knowledge in order for the robot able to speak, able to understand things surrounding and so on, because all the robots can share their knowledge together in a very efficient way. Right, so over here, we have done quite a few research work that focus on this kind of cloud computing things to connect with robots. And one of the example that I worked on a few years back is we try to learn certain skill or certain knowledge from human being, which is like throughout using internet, throughout the network. So we can learn some information acquired by interact with human, or maybe like human and robot interaction in a virtual environment. So this is a virtual environment that we put it on the cloud, so we can learn something. Then we can put this knowledge back to the real robot. So from here, we cloud sourcing the learning process on the cloud, and then we gather the information, we gather the knowledge, we put it into a database, and we can link this database to the local real robot. Right, so this just to show you one example and how the learning can be done. So over here, we design the scenario. For example, we want to create robots to assist in hospital, for example. Then you need to understand the operation of how the nurses work in the operation. For example, they need to get something when they receive this information, or they need to help out some operations and so on. So how you want to learn all these things. So what we do is, like, for example, we create a hospital scenario. Over here is a different scenario. So we create a hospital scenario, and then we observe how the human do something, right? Then we collect all this data, and then we build a database, and eventually the robot able to learn the same operation from this database. Okay. And this one is a comparison, like we only have a very limited data, like we only have data from 4 experiments, 16 experiments, and as the number of data increases, the robot able to be more, how to say, intelligent in this way, right? Which means it actually see more scenarios, which mean the robot have more knowledge or experience. Okay, so this 1 to 8 experiment is actually something like human experience. So when you have more experience, you know how to deal with the situation, because you experience more condition. So in different condition, you know how to react. So you can see, like, the robot able to finish the work faster in this case. Yeah, finish faster when you have more data. So this is one of the application. This is one of the research work that we work on how to acquire knowledge from the cloud and process this with machine learning, and then we can implement this on real robots. Okay, so another one is like another example with a similar concept is like we have a human-robot interaction or collaboration through this VR technique. So we have this virtual reality or AR, VR, AR, or mixed reality. You can design the interface. So we have real human actually deal with the robots to do some tasks. So over here is like the robot try to learn how to actually tell the robot to do something in a human understandable languages. I mean, like sentences. Okay, so because, for example, you want to ask the human to find something in the environment, you cannot give the coordinate because humans don't work in that way. You need to tell, like, okay, so it's in the living room, in this is on the table, or in the third upper cabinet, and so on. So how robot able to learn this kind of human interaction? So we use this kind of system to do experiment to see, like, which kind, how to actually improve the interaction between human and robots. Okay, right. Okay, so I have finished the first part about the overall, and okay, so now it's 11. So we go to the second part, right? But before we go to the second part, just want to show you, like, what is the robots that we develop, and also the system that you can learn to build in your house, right? Okay, so we start with this. So we extend. Chatterbot 2 is a very popular open source robot platform that comes with ROS. Okay, so it's a learning platform for learning ROS. I will explain more, introduce about ROS next week, but now just remember this name. Okay, it's an open source robot software framework that we can use a lot of how to say, open source tools. For example, like how to do navigation, how to do speech, and so on. So we have a lot of things that already packaged in there. Right. So over here, I show you the example that this is the robots that we built in 2014. Okay, this video was taken in 2014, and then this is the open platform that we use it for our education activities. And then the design is quite flexible. You can add on a different module on top in order for your to suit your application, right? So over here, we show you some example. Okay, then we have our approach is like we want to come up with a very simple basic platform, which is something like this. So this basic platform is like a Roomba base, a floor cleaning robot base, then with a 3D sensor, 3D RGBD sensor. So with that, we complete the basic unit for your navigation. Then on top, we put on different modules. For example, we put a laptop with mic and speaker, then you can have the human-robot interaction module. We have this arm with the eye on top, the visual perception, and also the arm. So this one will give you another set for manipulation and so on. So with different add-on, for example, like over here, I show you a list of components. So we have the base, which is just you can actually modify it from your floor cleaning robot, but I don't really recommend you do that so that you don't mess up with your mom, okay, by messing up the floor cleaning robot in your house. But we can start with simulation, okay, for this one. Yes, of course. But if you interested, yes, you can acquire this kind of base for your development. So over here, we use a Turtlebot 2 platform, which is using a Kobuki mobile platform as the base for mobile base, okay, mobile platform, right? Then we have the visual perception, which is the eye. So we use mainly RGBD sensor. Of course, you can use other sensors, laser ranging finder, and so on. But for simplicity, we focus on RGBD sensor. So the example that we use is like the Xbox 360 Kinect. So, but this one and also the Asus Action, they are already out of the market, which is like stop production and so on. So currently we're using the OBEC Astra sensor, which is very similar among these three. Okay, but now at home, what I will the example that I show you, you can achieve easily with just a webcam, right? I believe everyone have a webcam attached on your laptop, or if you don't have, USB webcam is easily available nowadays, right? Then for speech interaction, it's very simple. Okay, you just need speaker and microphone, which is already exists in your laptop, right? Okay, but of course for speech, for our service robot development, we have more, how to say, more features. Okay, for example, like we have microphone array in order for the robot to able to recognize the source or the direction of the sounds, where the sounds come from, so that the robot able to turn to the person or turn to the sound source, and also to avoid the noisy environment. So we have, for example, we use the shotgun, not the omnidirectional, but shotgun microphone. And also for the speaker, we might need to do some, how to say, we might need to use some better speaker that give you the quality, the loudness and the clarity that you need for the usage in your environment. Because in the noisy environment, if you are relying on your laptop speaker, it might be too soft. People might can't hear you, right, and so on, right? But these are all the components that you can easily available from the computer accessory. Okay. Then about the arm, so we use this is a more special arrangement that normally you don't have these kind of things at home. But we try to replace this with simulation for this class. But if you're interested, yes, you can actually build out. We have the hardware and also the design, right? And this elevator is like you can, yeah, if you can do something like this to reaching, for example, the actual table or the cabinet and so on. But this one is if you want to do it, okay, for a specific application, right? Then for the user interface, currently, if you're using a laptop, so your screen is something that you can use on. But of course, you want to replace with a touch screen monitor or anything, yes, by all means. It's just that maybe you need to find a way how to power it up and so on, right? But bottom line is, as long as you have a laptop, okay, we already have the user interface, okay, right. Then the software framework, yeah, we will introduce this one by one after this, okay, in different classes. We will show you how to do navigation, people recognition, voice interaction, and object manipulation, right? Okay, so these are all the specifications. And also over here, I would like to stress on is like, I show you the basic, but I hope you can actually put in your creativity to create the robots that you want, or the robots that more suitable for application. Because you can think of, now you're at home, you have a lot of things you can do. For example, like you want to do a robot that's able to move around. I don't know, depends on what you want. So you can move around and talk to a person, or look at someone, or track someone. For example, you want to have a robot that track your babies, you want to track your brothers, and so on, and then take pictures and then do something, right? So you have a lot of things you can brainstorm, and then I will show you how our building blocks that you can assemble them together to realize this kind of project, right? Okay, right. So over here, we also, like the student, my student actually like have different configuration, different design. So please be more creative with whatever fundamental things that you learn from this class to come up with your version of service robot that you want. Okay, so so I turn it back, so I don't put the human metaphors anymore. So I put back like this will be the technical terms that we use. Not very technical, but I think you can understand. It's just that maybe not so attractive for children. But yeah, so we focus these 5 components, and I will explain these 5 components in the coming weeks, one by one. And also I will show you a real example. For example, like speech. So what you can do with speech. So after the end of each class, for example, the speech, you'll be able to create a system like your smart speaker. So it's able to hear what you say, it's able to process, and you have a database how the robot's supposed to respond, just like your series, right? Then it's able to tell you it give you some feedback that is something that you can understand. So you can use it to interact with other things. And of course, in your database, you can create, like if you detect this word also, you can command the robot to do something. For example, like you ask the robot to dance or to sing, then the robot is able to play some song and do some movement, and so on. Yes. So that is something you can do. And for the vision, I'll show some technique about face recognition, face detection. Then you can combine this face detection recognition with your speech. Then the robot able to, like, for example, it meets your family members, then it can read like good morning. So it depends on the time because we know the context and so on. So it can detect, and yeah, it can entertain your guests and so on, right? Then we have the mobile platform. So if you have the hardware, right? So if you have the hardware, then you're able to move around to do the very interesting thing. Okay, but of course for the arm as well, you need to get something. Yeah, but for the mobile platform and the arm, because it requires specific hardware, so we'll do it in the simulation. But don't worry, I mean, like you can learn how to do it with just your laptop. Okay, regardless what. Even if you have an Apple or Windows, we'll try to figure out how to make it work. Then lastly, also, I will introduce you some machine learning techniques, but maybe not very complicated. I'll show you some tools. I'm not going through all the very detailed mathematics and so on, but I'll show you some, like how you can use this tool to do something, how you can do the learning and so on, right? Okay, and also the cloud computing, particularly, we use a lot. We use a lot of API, the speech API, the vision API of Google and so on, in order to enhance our perception, enhance our speech module and so on. So these are the things. And over here, so you can see like from 2000, this is 2015, so 2014 version 15, and now the 2019 version is like this, right? So this is 2019 version. Okay, but yeah, you are freely to design your own robot after this. Okay, then the resources. Okay, so I gather everything here. We have the coursework, we have the online classroom, which is this session. So you can get all the information, the wiki, and all our source code you can download from here, our video and example. Okay, right. Then we have all these examples. So I will use this example to explain in the coming class, like, okay, for example, we will use the speech. So how to build the speech. So you're not going to write the code from a blank screen. okay, a blank street. You are not going to open up a blank template or blank, what we call it, a blank notepad, and then you start to write from there. It's not going to be like that. So I'll show you some example that you can open up. You already have something is workable. Then from there, you enhance, you try to connect that, you assemble these kind of features together. For example, you have the speech, vision, you put them together and you configure the logic so that it will, you can do some application. So that will be the process of how I conduct this online class and how you can learn from here. But of course, all the source code given are all, I think like many, yeah, all open source. So you are free to read all the lines to understand and improve from there, right? But of course, if you don't yet have the fundamental thing, you can always use this tool as it is. Then slowly, when you are more comfortable, you dig deep into it and look at the detail. Okay, so this is the first session, materials. I'll go to the second session, materials. So this is the second one. So I'll start from here. So since we already like very different from the session time, so we will just continue.